Thank you very much. Thank you very much, everybody, for your patience and welcome. It's great to see you all in this Snyk webinar, in which we're going to be touching upon a very, very important, and I should say also a hot topic of software supply chain security. So my name is Daniel Berman, Product Marketing Director here at Snyk, and with me here, I'm happy to be joined by my colleague from Snyk, Michael Comrades, whose team, the Snyk Labs team, has been investing a lot of time in researching the whole topic of software supply chain security, and I'm really looking forward to get his insights later on in the webinar. Hi, Mickey.
Nice to meet you, folks. Thank you, Daniel.
Great. So what are we going to be covering today? Well, before we actually go into some definitions and define what the software supply chain is and what software supply chain security means, mitigation strategies and so forth, we're going to take a couple of steps back and start with some level setting and try and understand why we're even talking about the software supply chain today. Why are we talking about the whole topic of software supply chain security? It's not a brand new topic, and is an important point to highlight. So what's changed, right? Next, after we go through that context setting, we'll dive into some actual definitions and we'll try and understand what the term software supply chain actually means. We'll then, of course, look at the security aspect and we'll dive into the risk, the actual risk that software supply chains and software supply chain attacks pose to us. And we'll try and figure out why they're not only increasing in number, but also becoming more and more complicated. We'll then try and get a bit more practical. We'll take a look at some best practices and steps that we can actually take in order to mitigate this risk. We'll wrap things up with a Q&A session at the end. So if anything pops up during the webinar, please feel free to pop those questions in the Q&A box, the Zoom's Q&A box, or in the chat, and we'll do our best to keep track of these questions and answer them time permitting. Great. Let's get started. So like I just said, we're going to start by taking a couple of steps back and just setting up the context and understanding why we're even holding this conversation about the software supply chain. So it was Mark Andreessen, the famous CEO and founder of Netscape, who coined that famous "software is eating the world" phrase in his famous "Why Software is Eating the World" essay in the Wall Street Journal in 2011. Now, since then, the fact that, or the idea that every company needs to be a software company, every company is a software company, is almost a cliche, right? Because since the time that he coined that phrase, and we're talking about something like 11 years ago already, there's been a huge explosion of software all over the world, right? We live in the era of digital transformation, where everything we do, right, every service that we consume and use, it's all powered and using software. And this is from ordering your food, your lunch, taking a ride on Uber, just booking your next vacation or flight, or even having a virtual meeting with your doctor. Believe me, I did that 2 weeks ago. It works. And so all of these activities are powered by software today. And it's this digital transformation that we're experiencing. It's also pushed organizations to innovate faster, deliver functionality, features at a much, much faster rate. It's the only way that businesses today can actually survive and stay competitive. And this doesn't matter what vertical you're talking about, what industry, what part of the world. It's true across all these different types of companies. And this specific need to deliver and innovate faster has resulted in some pretty major changes in the way that software is actually being built. So if once upon a time, your developers, you had them in your organization writing all the code, all within your perimeter, all within your purview, and that code got built, it got compiled, it got bundled and chucked over the wall, to the folks in IT or operations. And their responsibility was to actually rack up the infrastructure needed to actually run and deploy this code. Again, usually within the organization's purview, within the perimeter, right, on on-prem data centers, usually. Now, when you think about how modern software is being built, that scenario sounds like fantasy almost, right? One could almost be so bold to say that there is no such thing as a perimeter anymore, right? Even IDEs, right? The actual tools and environments where developers code are also shifting to the cloud. So there's very, very little that the organization itself still has control over. So again, to support that fast pace of innovation that we just mentioned, that's so important to help companies stay competitive. Software development today, well, uses methodologies like Agile and DevOps, right? Where developers are pulling in open source to build their applications. They're using cloud native technologies like containers, and they're using infrastructure as code to actually provision cloud infrastructure. And what all of that means is that suddenly you've got a long, long list of different third-party assets, right? Assets that are outside your purview, outside what we used to call our perimeter, that all contribute to the building and deployment of your software. And of course, this list is just getting longer over time. It's just getting more complicated and diverse, and hence extremely more difficult to control and, of course, secure. And that's why we're talking about the modern software supply chain. Okay, so now that we've got that context in place, we understand why we're talking about the software supply chain. What is it? Let's dive into some definitions just to make sure we're all talking about the same thing here. The idea of a supply chain, all right, on a high level isn't new, right? Most of us here are familiar with the manufacturing supply chain. And that's a great way to use as an analogy to help us understand what a software supply chain is. So in those more traditional manufacturing supply chains, you've got a variety of activities that transform raw materials into a finished product. So if you take the car that we drive to work, or used to drive to work before COVID hit, that is, the supply chain is first and foremost all the different components that assembles or comprises the car. So you've got your wheels, your chairs, the fuel tank, etc. And those, of course, are also assembled from raw materials like plastic, iron, etc. Now, some of these parts are actually supplied to the car manufacturer, right, by other suppliers. And this is an important point when we try and understand the software supply chain as well. And so these suppliers have also got their own supply chains. But importantly, the supply chain isn't just these physical building blocks, isn't just these physical components, it's also the people, it's the tools, it's the processes all involved in not just producing and manufacturing the car, but also delivering it, selling it, marketing it, etc. So enough about the traditional manufacturing supply chain, time to take that analogy to software. So in the software supply chain, development processes transform code into software. So for any app that we're using or building, if you're a developer, the supply chain, of course, is first and foremost the code, the binaries, all the other components making up our code, making up our application. But it's also the developers themselves, the tools and the processes that they use to build and package and deploy that application. Now, if you take a look at this diagram here, that's really meant to give us a high-level depiction of what the modern software supply chain looks like. And we'll start on the left side here. You've got your developers, right? And whether that's their local development environment, their IDE, it could be their actual desktop that they're using, and of course, the actual code that they themselves write. Now, it's not just the code that they themselves write, because today, again, to support that fast pace of innovation, they're also increasingly relying on open source packages to build their applications. And they run these applications in ready-made container images. So they're pulling in different ingredients, third-party components as well. And all of these ingredients are open source, available for anybody to pull in with little to no security scrutiny. And all these, again, help fuel that fast pace of innovation. Now, these different building blocks are all usually managed on an SCM, a source code management system like GitHub or Bitbucket, GitLab, etc. And then they're pushed into build pipelines, right, to be continuously tested. And eventually they get compiled into artifacts, which get stored, deployed, delivered to the end user as our end product, which is the software itself. So that is, in a nutshell, what the modern software supply chain actually looks like. Now, each one of those different building blocks making up the modern software supply chain can be thought of as a link in a chain, right? And each one of these links can actually be targeted as part of a software supply chain attack. And we'll see one example of such an attack later on, but this is what makes this type of attack so special and, in fact, dangerous. Over the past few years, I think most of you here can agree, it's been absolutely impossible to ignore the rising number of attacks, software supply chain attacks taking place, and in the headlines. Again, software supply chain attacks aren't new, right? But recent high-level attacks, right? You've got SolarWinds, you've got Kaseya, CodeCov, etc. All these have definitely helped bring the topic to the forefront of awareness, both the awareness of the cybersecurity community, but also that of governments, companies, organizations, etc. Gartner, in fact, predicts that by 2025, almost half of organizations across the world are going to have experienced an attack on their software supply chain. That's pretty an amazing number. That's a threefold increase from 2021. I think I mentioned this before. Attacks are not just increasing in number, they're also getting more and more complicated and now also involve state-backed entities as well, the so-called APT actors, right? Advanced Persistent Threat Actors. So why are we seeing an increase in attacks? So at this point, I'd like to hand things over to my colleague, Mickey, who's going to kind of dive a bit into the ins and outs of a software supply chain attack, provide us an example so we can actually understand what's so unique about them. Mickey, all yours.
Thank you, Daniel. So let's speak a few minutes about how do these software supply chain attacks actually transpire. So Daniel before explained how does the modern software supply chain looks like, from code to building, assembly, distribution, and delivery. An important thing to note is that over the past decade or so, software supply chains transformed, undergone the same transformation as cloud native software. They became ever more distributed, so open source dependent, and constantly changing. And with this, a new problem arises. So what is the problem? Software supply chains are complex and opaque, making it impossible to trace and verify how software is being delivered and arriving into the premise of our organization. This in turn leads to us relying on implicit trust in anonymous systems and maintainers. Because there's nothing we can do about verifying the origins of software, we sort of resort to assuming that if we download the software where we expect it to download, it's probably okay. This in turn creates weak links to the chain, which, as Daniel said, are very lucrative to exploit. So how does it look like in practice? If we look at this software, the internal pipeline of software, how software is built, we have the coding, we have the code management, the build, the assembly line, and then distribution all the way to consumption. One category of attacks is compromise of application dependencies. So the same application dependencies that we're used to working with, whether it's application dependencies or containers, which is another sort of application dependencies, could be compromised, prone to supply chain attack. Even an apparently perfectly normal, non-vulnerable dependency could be a victim of a supply chain attack because of compromise somewhere in its own supply chain, which leads eventually to a compromise of our application. The same thing applies to build dependencies. All of our CI plugins, the build tools, the build environments, all the things that we put in the CI/CD that are the machines, sort of, that are used to assembly of software, also have their own supply chains and are also vulnerable to supply chain attacks. If they get compromised, they in turn compromise our own pipeline and our own application. The third category of supply chain attacks is compromise of the pipeline itself, our own pipeline, whether this is unauthorized access to the code manager or to our distribution mechanism or to our developers, the identity. So let's take a look at a very famous or infamous rather example from the past year, CodeCov, and see how this actually transpired in practice. So CodeCov, for those that don't know, it's a very immensely popular code coverage, test coverage tool used by developers. Immensely popular, and their favorites before, their recommended way of integrating CodeCov in pipelines was this, what's called curl to bash. Sort of CodeCov publish a bash script on their website. The development team in their CI adds this kind of step. The script downloads into the CI environment, collects all the test statistics, and uploads to CodeCov for later interrogation for a statistic. Somewhere in March 2021, last year, somebody discovered that the bash script on CodeCov's website, codecov.io/bash, actually differs in signature from the script that they downloaded. Turns out a malicious attacker substituted this script in the CodeCov's bucket, S3 bucket. How this actually happened? So CodeCov, besides the script, also offered the GitHub action as an integration option. And this GitHub action is based on the Docker image in which CodeCov made a mistake and leaked a token, an S3 bucket token inside this image, which allowed the attacker to use this token to substitute the bash script in production in CodeCov's website. This in turn, they substituted the script and added a malicious piece of code that collects all other environment variables. This was the second stage of the attack, where all of CodeCov's customers, which, as I said, are very numerous, including very big companies, immediately became prone, a victim to supply chain attack, because they started downloading this malicious version of the CodeCov script. So if you look at back at the previous slide, we can see here two steps. CodeCov itself was a victim to a pipeline, compromise of the pipeline, where the attack was in the distribution mechanism, their S3 bucket, which in turn made their customers being a victim to supply chain attacks through a compromise of their build tools. So this is a very beautiful example showing exactly how these attacks transpire and the risks. Yeah. Daniel, I guess it's yours now.
Great, thank you, Mickey. So we've seen an example of what a software supply chain attack looks like. We understand the risk. We understand why we're talking about software supply chains in general. So what can be done, right? What steps can we actually take? So what we're going to try and do now is get a bit more practical here, outline a framework of sorts for actually, again, taking action, taking some measures to try and mitigate this risk. Now, before we dive into the details of what this framework could and should look like, let's definitely highlight the fact that the whole field of software supply chain security is still very much an active field, right? A lot of organizations, a lot of companies are looking into this, governments are looking into this. And so there's a lot of noise around that. But there's a growing variety of different models and frameworks that are starting to become more and more acceptable and coming to the fore. Now, when we look at all of these different models and frameworks, there's definitely some common thread or commonalities between all of them. And we can take these common building blocks and actually use these as our framework. And these call for specifically, first, for securing your code, right? And we'll talk about what that actually means in the next slide. Securing your development pipelines. And last but not least, the third building block is using the principles of the DevSecOps model. Okay, so 3 building blocks are emerging as the building blocks of a framework for securing your software supply chain. Secure your code, secure your pipelines and their dependencies, of course, and DevSecOps. Let's take a look at each one of these building blocks. Right, securing your code. Now, code, of course, is the raw material that we use to actually build our software, right? And so, needless to say, it's the key ingredient in any framework for securing the software supply chain. Now, the challenge here, of course, is that there are different types of code that make up our applications today. And we talked a bit about that before. So first and foremost, you've got the actual code that your developers write. You have to make sure that that code is scanned and tested to make sure there aren't any security issues within that code. And for that, you can use static application security testing, right? Or a SAST tool or methodology. But again, like we mentioned before, increasingly developers are pulling in third-party components from different types of sources, which also need to be analyzed, tested, and secured. And to do that, you could use software composition analysis solutions, or SCA for short, and container security tools as well. And these will help you test your application, test your code, test these third-party components, in essence, to help you identify and fix, of course, any vulnerabilities that are found. Another type of code that we did refer to before when discussing the modern software supply chain, these are infrastructure as code configurations. More and more developers are also writing that code, the code responsible for actually provisioning infrastructure used to run their applications. Now, developers don't necessarily have the expertise to understand whether these configurations are secure or not. And so also this type of code, again, increasingly becoming an integrated part of your application, needs to be secured. And again, you've got dedicated infrastructure as code solutions that can help you out here. So whatever type of code that you're securing as part of tightening up and hardening up your software supply chain, you need to do this continuously throughout the software development lifecycle. You need to do it again and again as much as possible. And preferably, you need to automate that. We'll talk a bit about automation when we talk about DevSecOps. Now, there's also been a lot of talk about SBOMs, right? And probably because they played a big part in President Biden's executive order, which followed the SolarWinds attack. And SBOMs are definitely an important component in any framework for securing a software supply chain. They help you document or share documentation about the different ingredients making up your applications, but they're only useful if you actually use them, meaning don't just produce an SBOM because you want to check off a box. Look at the SBOM, look at the list of ingredients, and look at the risk that they're introducing. All right, moving on to our second building block here, securing your development pipeline. So we said the code is the raw material that we're using to build our applications. Your development pipelines and their dependencies are the tools and the processes that transform this raw material into an end product. As we saw in the example that Mickey just showed us, the CodeCov example, attacks, software supply chain attacks, are increasingly targeting this specific link in the chain, just leveraging the fact that these pipelines, these development pipelines, are becoming more complicated than the actual software that they're supposed to be producing. So what can we do here? Well, first off, we start with the build pipeline, right? The build pipeline itself is the obvious starting point. We need to map out the different steps making up these pipelines. This will give us a nice picture of all the different building blocks and steps making up these pipelines. Now, as a general best practice, it's always a good rule of thumb to try and use secure, hardened, approved container images and artifacts. You can use checks and verification tools as a good method here to do that. So build pipeline is one step here in securing your development pipeline. The source code management system, the SCM system that you're using, is another potential weak link here. And there's some good news here, because all of the modern SCMs that we use, like GitHub and Bitbucket, all have built-in specialized features like, I don't know, access policy controls, branch protection, etc., that can actually help us keep these this system secure. There is one note here that needs to be considered, and that is that some of these options aren't always enabled by default, so you actually have to explicitly enable them. Something to think about. Other than that, we've got all the different third-party tools that we might be using as part of our development pipeline. So it could be the developer's IDE, right? It could also be different open source build tools that we might be using, like Jenkins, right? So we need to make sure that these, in fact, are also secure and not introducing risk. So if I'm using a vendor who's providing me with a build tool, I can actually ask them for an SBOM, just like we'll be required to produce an SBOM for our software. We can actually require an SBOM from vendors to make sure that we're not introducing risk simply by using these third-party tools. And then we've got another category here that fits into that securing your development pipelines building block, and that is the privileged credentials that we use to usually access our code and access our scripts and tools, etc. So it's sensitive information like passwords, API tokens, SSH keys, etc. All of these need to be secured as well. And there are dedicated point solutions to help you do this. You can use secret management tools. You can rotate your passwords and secrets, use encryption, of course, as always, best practice here. So there are ways also to secure this specific part in your development pipelines. All right, so the third building block is DevSecOps, right? On a very, very high level, DevSecOps talks about integrating security practices into the iterative DevOps software delivery model. Now, the heart of DevSecOps is a culture, right? A culture where all the different teams responsible for developing and deploying software. So you've got your developers, you've got your security folks, you've got your operations folks. All of these teams are enabled via process and tooling to share responsibility for delivering secure software. That's the foundation upon which DevSecOps is based. Now, the reason DevSecOps is brought up as part of securing the software supply chain is because a lot of the key elements and principles of the DevSecOps model align beautifully with tightening up and hardening up your software supply chain as well. So we talked a bit about this before. Automating security testing and validation, right? As much as possible during the development lifecycle is one of these principles. Making sure that you're repeatedly testing and doing security testing throughout the different stages and early as possible within your software development lifecycle. Again, another principle here, part of DevSecOps, and definitely something that can be considered as a best practice for securing your software supply chain as well. It's no surprise that President Biden's executive order also explicitly calls for using automated tools and processes for helping us secure our software supply chain security as well. Now, of course, DevSecOps, just like DevOps, is a long-term effort, a cross-team effort, and definitely something that you can't achieve overnight, but its benefits, right, not only for helping you deliver secure code faster, but also for securing your software supply chain is definitely worthwhile to consider and can't be overstated, I think. So those are three main building blocks that we're seeing emerging as part of all the models being proposed for securing software supply chain. It might seem like a lot to take in. So perhaps a good starting point here is to use some of the work that's already been done in the space by both the open source community, various organizations and companies who've all, risen to the occasion, accepted the challenge, and responded to the risk of software supply chain and the attacks that we're starting to see take place. And they've already put some skin in the game, so to speak, and they've put together some guidance, some steps to help us really start with our mitigation steps. So you've got the Linux Foundation and OpenSSF. Snyk also supports those, by the way. You've got the CNCF, you've got the NTIA. These are just a couple of examples. So you've got a lot of documentation, a lot of good resources out there, free to use, and a good place to actually start out. At Snyk, we've also put together a couple of resources here that can help you out and just help you internalize all of these different principles within your org. We've got a white paper on the subject, which really puts together a nice overview summary of what we learned today in the webinar, but also dives a bit deeper into those mitigation steps and into the proposed framework for securing your software supply chain. We've also put together a cheat sheet, a one-page easy reference, just to, on a high level, to put together some actionable steps to help folks understand, raise awareness, and understand how to tackle the whole topic. A very good resource if you want to go back to your org, share with developers, and again, just make sure everybody's aware of this rising challenge. So that's pretty much what we had to deliver today. What we'll do now is take a look at some questions that we got and answer these time permitting. So let's start off. How can we get developers involved with software supply chain security? So I think this is something that's very similar to how to integrate security as a whole in an organization, how to empower and get developers on board to start with. So it's all around enablement, it's all around awareness and training. So you could use this webinar, right? This would be your first step here, but all the information that you got here needs to be disseminated in the organization, needs to be shared with your developers, and you can use that to kind of raise the awareness. Of course, just raising the awareness is not going to be enough. You need to actually take it an additional step and actually help developers take action, using specific tools that don't interrupt development, go along with the developers, fit in nicely into the way they're already working, definitely goes a long way. Next, and this is pretty similar. We don't want to start adding gates. How do we maintain a balance here? Mickey, do you want to take that one?
Yes, thank you, Daniel. I think that's a great question because with our whole intention with FSecOps was that we empower developers and development teams to own security. But at the same time, we see that if we empower too much, we kind of fear of losing control and opening the organization for supply chain attacks. And so there's a good question of how do we balance the two? In our opinion, taking the control back from developers is not the solution because it will ultimately slow down their development. The solution really lies in educating developers on the attacks and giving them tools to make the right decisions, judgment calls. For example, things like the Snyk advisor that allow you, before even choosing dependency, look at some statistics on the maintainability, on the maintainers behind the package. And then as an organization, we need to put some guardrails as to what level of risk we allow where in the organization. And by balancing these two, risk versus speed, this is how we can find the middle way.
Okay, great. Let's take another look. All right, this one is hitting the nail on its head. What does Snyk do to help with securing software supply chains? Well, I think first and foremost, something that I already mentioned, right? Software supply chain security is still very much something that's evolving and developing, and it's this huge and wide field. We did mention that one of the building blocks here that we mentioned before is securing your code, right? And that means your custom code. It means, again, your open source, the packages that developers are pulling in, your containers, and infrastructure as code. So Snyk customers and users are already using us to actually secure code during the different stages of the software development lifecycle. So that's one part of it. Snyk Advisor, I'm not sure everybody here has heard of Snyk Advisor. Snyk Advisor is a free online tool that we provide, and it enables you to actually look at different open source packages that you're pulling in even before you're pulling them in. So as you're researching which open source package to actually include in your supply chain, so to speak, you can already see if it's a malicious package or not. You can see if there are any known vulnerabilities, etc. So that's another step that Snyk helps you out with your supply chain. You can use Snyk to produce an SBOM of sorts. Again, this field is evolving. We're investing heavily in this, and you can look forward to see a lot more coming from us in the future. Mickey, do you want to add anything there, or do you think that covers pretty much?
Yeah, I think you got it right.
All right, good. How can you integrate Snyk tools with Azure to Azure DevSecOps? So Snyk integrates with Azure at various integration points within Azure environment. So Azure repos, for example, Azure DevOps, etc. And that enables you to actually implement testing, security testing of all those different components that we just mentioned, making up your application in an Azure environment, just as you do in any other type of environment. So you're more than welcome to check out our online documentation and product information about Azure. And if there's any follow-up questions on that, please do let us know. Let's see what we have here. Yeah, one more question. Where do you see software supply chain attacks going in the future? What should we expect? Mickey, that sounds like one right up your alley.
Yes, thank you, Danielle. I think we're going to see more and more of those, really. So one thing to remember, software supply chain attacks in general, and software supply chain attacks is not a novel threat that the industry haven't heard of before. But what I think happened in 2021 is that we reached a tipping point because of the amount of open source, because of the complexity of software pipelines, and because of the promiscuous of developer tools and the complexity all around this, attackers realize that there is a very high ROI kind of an attack vector on on cloud applications. Because application can be as secure as you'd like it, like no vulnerabilities, no cloud vulnerabilities, nothing open. But these dependencies, all this tooling, the software supply chain, the long one, is sort of a soft underbelly. And especially given few of the prominent and famous attacks in early 2020, I think there's lots of copycat attacks. I think it opened eyes to attackers of this possibility. And so we as an industry also need to raise the bar back. And we're doing this, but until we do this, I think we'll just see an increase of more and more.
Yeah, I agree with that. All right, I think that pretty much wraps things up. Unless anybody else wants to pop in a question into the chat or Q&A. All right, so again, I'd like to thank Mickey for joining us and sharing his insights from the Snyk Labs research, and everybody else here for joining. We will send out a recording of the session later on together with a link to the deck. So have a great day. Thanks for joining us.
Thank you, folks.